Welcome. In one of the videos, we had a look at how we can solve some problem using parallel arrays. But in this video, we are going to see how we can use a structure to solve the same problem. And instead of using the parallel arrays, we are going to use structures. So before we answer this question, we'll first have a look at the difference between the last lab and what we will have in this lab. That is the difference between the primitive data types and a struct. So some of the data types that we already know, they are integer, we have char, we have boolean, we have character, and we have double float string, and those are the ones. Now what these values hold, they hold only one value. So for this particular variable at this location, we can store only one value. So if I want to store the numbers, whole numbers, I will store them in these data types. So they are the data types, and we have these character. So character can store only one letter or one character or one number. So any character can be stored by this character variable. Boolean, it can only store true or false, so either 1 or 0, true or false. So double can have the floating point numbers, something like 4.5. all right. So these are called the primitive data types, right? They come built in and we can just use them out of the box. Now the creators of the C++ have given us these options, right? But in real world, there can be tons of many other scenarios where we want to have our own data type. Now in this case, if we want to store a number, we will use integer for whole numbers. If I want to store a decimal number, I can use the double. But what if I want to store the details of maybe a car, right? So a car can have many properties. A number is only one value, but a car can have many things. Let's say maybe we can have the weight of the car, then maybe the length of the car, maybe the horsepower of the car, radius of the tire, the car model, and many more. So can we use any of these primitive data types to store all these details? That is not possible, right? So what we can do is we can create our own data type. So just as we are given these primitive ones, we can create our own data type and store these details in the data type. And each of these single attributes that we have can be represented by these primitive ones. What if we want to store the details of maybe a tree? So a tree maybe can have the height, maybe the radius of the trunk. What if we want to store the details of a university student? So he or she can have the name, age, and if you want to look for a particular exam, then we can have the mark, we can have the grade, we also have the ID, and so on. So what we can do is create a struct, and the way we define a struct in C++ is we use the struct keyword followed by the name of the struct, or we can say the data type, and then in curly braces we will write these single attributes. So all of this goes in here. Now the data type for this one is, for the first one is integer. The data type for this one is student, right? So the data type of this one is integer, for this one is student. The difference is this is a primitive data type and the one that we have created is a complex data type because it can store many things. So what if you want to assign the values to each of these data types? So if you want to use a integer, so I can say integer x is equal to maybe 5. So what will happen at the location x, right? The value 5 will be stored. If I want to store a character value, then I can say cha maybe c is equal to I, right? So in the memory at the variable c, the value I will be stored. But what if I want to store the details of a student? So in the same way, I will have to declare a variable of type student, right? Because the data type here is student. So I will say student because that is the data type, and we can give a variable name, maybe S1. But how do we store the details in this variable? Now for the student, I have many components. I have the name. So let's say the name is of type string. Then we have age, maybe int. We have string ID and so on, right? Now this has three properties: ID, age, and name. So I cannot just simply say student S1 is equal to some ID or name, some name, right, and the age, because this S1 has three components. So you want to tell the compiler where do you want to store these values exactly, right? So for that, what you will do is you will use the dot operator. For these ones, there was a only single component in the memory, right? We have one place to store 5, one place to store I. But for this one, each variable will have three components, right? Because in the data type, we have name, age, and ID. There are three things. So for this one, there are three things as well. One is for the name, the other is for the ID, and one is for the age. So if you want to store the name, you will have to say that in this student1 variable, for the name attribute, I want to install the name and something like that. So this variable has three components: name, ID, and age. So I want to store the name for the name attribute. So you will have to use the dot operator to access each of these individual component. So after this, the name Krish will go there. Then what if you want to store the ID? So you will say s1 dot ID equals some ID, right? What about the age? So once again, s1 dot age is equal to 25, something like that. So all of these values will be stored over there. And then what if you want to print the values? So you will say cout s1 dot name. So this is going to print the name. Notice the difference between this primitive data type and this complex data type. If you want to print the value of x, you will just say cout x, right? But for the complex one, you need to tell which attribute you want to print. Now let's try this in our Visual Studio. I'll create a new project. I'll call it a structure demo and create. Source files, right click, go to add, new item, C++ file, give the name as main, click on add. Alright, so I'll declare some primitive data types. So I'll have int x is equal to 5 and maybe double num is equal to 4.5. And I'll run the debugger to see what happens in the memory. So I'll press F11 button on my keyboard. This will bring up the debugger. And then in the watch window at the bottom, I can add these variables. I'll add x and I'll add num. So we'll be able to see their values. So when I skip into the code, step into. So when line number 7 will run, you will see that the value of x will change. And you will see that there is only one component where that value can be stored, right? The value is 5. The value of double is 4.5 and all of these zeros. So that is simple, right? We know that. Now to create a struct, You will write the keyword struct, give the name, maybe student in our case, and we have string id, float mark, and maybe char grade. So I have the id, mark, and grade. So I'll stop the debugger and write some more code to work with the struct. So I'll declare a student of type student, right? And then I'll try to set the values for student. So I can say s1 dot. So notice when you put this dot operator, whatever is inside my student struct will pop up. So it says grade, id, and mark. So it is giving us option from those variables or attributes to store our data in. So let's go with the id. So I will say the id of the student is s11. Then s1 dot mark is, let's say, 90, and s1 dot grade is equal to, let's say, a. Then if I want to print the values, I will say s1 dot id. So let's print only one of them. And now when I run this, right, we get s11. Right, if I just do cout s1, run, we get some error, right? So because there are three components, right, we want to know which one of those we want to access. So I'll have to say s1 dot id. Now I'll run the debugger once again and see how it behaves. So I'll add the student variable, which is s1, to our watch window. And now you will see that in this one we have three components. We have the id over here, right? We have the mark, and we have the grade. Right? Because now this data type has three components. We have the id, mark, and grade. And that is why you are able to see all of those three inside this s1 variable. For x and num, you will see that there is only one component because that's a primitive data type. Now step into. So the value of x is 5, the num is 4.5. So you will see that when this object was created, s1, the value of id is initially empty. Some random values given for mark and for grade as well. All right. So when line number 18 will execute, the value of id will change. So from these three components, the value of id will change to s11. Step into. So id is now s11. So for this s1 object, out of the three attributes, we have initialized the value of the id. Then step into. So the value of mark was changed to 90. And then likewise for the grade is now a. Now you will see it is saying grade is equal to 65 and then a. This 65 that we have is the ASCII representation of I. So in memory, what it stores is the value 65, but the value of grade is I. So S1 is the student variable. Just like we have the X of type integer, we have this S1 of type student. Stop the debugger. I'll remove this code. So the question says convert the parallel arrays of lab2 into a single array of students struct. Here you need to create a student struct as shown below. So I'll bring the code from our last lab. I'll copy this code and paste it in my Visual Studio. If you don't have the code, you can refer to your last week's lab, or you can just copy from this recording. And this is the code that we had from the previous lab on parallel arrays. So we had two components. One was for the reading data from the console and one for from the file. So I'll remove the one for reading from the keyboard. We'll just work with the file. So right now, if I run this code, you will see that it doesn't run because we don't have the file. So I'll also bring the file, the students.txt file, and I'll paste it in my project folder struct demo in the same location as my main.cpp. And now when I run this code, it should work. Right, so we get the ID, mark, and grade. So we have to create a struct of type student, and the student has the ID, mark, and the grade. Then inside our main function, instead of these two parallel arrays, I'll remove these two and replace that with the student array. So I'll create a array of type student. So student, let's call this students. The name of the array is students, and the size of the array, let's set it to capacity. So now what we have is something very similar to what we had before. We had the data type, name of the array, and then the capacity. So we have the data type, student, name of the array, and then the capacity. Then where we are reading the file over here, now instead of reading into these IDs and marks array, which we don't have any more, I'll store it in my students array. So the name of the array is students. So where do we want to store? We want to store at index size, just as before, array name, and then the index where we want to store. So same thing over here, array name, and then at which index you want to store. But if you recall from this over here, each object has multiple components. So you want to tell at which of those components you want to store the value. So same thing over here, I want to say that I will store at the attribute ID. So at ID, I will store the ID that we have read from the file. Then same thing for the mark. So for the mark attribute, I will update the mark. So we have read the ID and mark from the file. Then in the students array, at index size, for the ID property, we are updating that to the one that we have read from the file, and same for the mark. Then increment size. Then at the bottom in this print function, we were passing the IDs and marks array, and now we only have to pass only one array. This is also another advantage of using struct. Imagine we had 5 arrays before, right? Then in that case, we will have to pass all of those 5 arrays. But now since we have only one array, we can just pass only one. Then in the function declaration, we will have to change this to student, give the name as students or any other name that you prefer. So now it is taking an array of students as well as the size. Then inside the function, we have to go over each of the indexes and print the value at index I. But once again, so you want to tell which one you want to print. So I'll first print the ID, then I'll print the mark, and then to get the grade, we will have to pass the mark. And this is how we get the mark. So we'll pass the mark to the determine grade function to get the mark, to get the grade, and then we print. Now I'll run this and see if it works. Okay, so it works, and we get the same result as before. So we have the ID, mark, and grade. Now there are many ways of working with all of those. So right now we are printing the grade separately. So we are getting the grade separately and then printing over here. But since our struct has the grade built in into the data type, what we'll do is we'll try to update the value of grade as well, because right now we haven't used the grade property of the student. So what I'll do is, while we are reading the ID and mark, at the same time I can also set the grade. So I can say the grade of the student. And how do we determine the grade? Well, we call the determine grade function and pass the mark. So we have read this mark from the file. We are passing that mark to this determine grade function. Once we get the grade, we set the grade for this grade attribute. And now in our function, we don't need this anymore. And over here, we can just call or get the value from the grade property. All right, so now when I run this, we get the same thing. Now I'll try to run the debugger and see how it works. So I'll add some variables. So I'll add the students array, and I'll add the size, and I'll step into. Right, so the students array was created. Now if you look closely, then we have this array of size 10, right? You can't see all of those values, but we have this curly brace over here, right, which we know indicates an array. And in the first index, you will see that we have a comma over here. So before that is the index 0, then we have the second part over here, which is the index 1, sorry. So in the first index, we have the ID, mark, and grade. Then in the second one, we have the ID, mark, and grade, and so on. Then when I step into the code, we go to read the file. We read the first line and discard it. Then we go inside the while loop. So we get the value of ID and mark from the file. Now you will see that when we'll run line number 55, the value of this ID will change, right? Only this one will change. So now the ID is S and 11. I'll also add, let's add the individual indexes. So I'll add index 0. I'll add index 1, index 2, index 3, index 4, index 5, and index 6. So you will see that each of these indexes, right, have 3 components: ID, mark, grade, ID, mark, and grade. So as I step into the code, you will see that each of the indexes will update. So we have gone into this function to determine the grade, and then we'll come back to the while loop. So after that call returns, the grade is updated to D. Then the same happens with every other index. So you will see how the values of each of the indexes change. Right, so as I step into the code using the debugger, you will see that each of the values, they change. And notice the value of size is also changing. Right, and that was the last one. So that is how each of the indexes in this students array is updating. So at this point, when the while loop ends, all the values in our array has been updated. Okay, so that was all for the video. Thank you for watching.